For this problem on the topic of electrostatics, we have an electron with kinetic energy K traveling along the positive x-axis. It is along the axis of a cathode ray tube as shown in the figure, and we have an electric field of 12 times 10 to the 4 Newton per Coulomb pointing in the positive y direction between the plates, which are 0.6 meters long, separated by a distance of 0.02 meters. We want to determine the minimum initial kinetic energy the electron can have and still avoid colliding with one of the plates. Now, from Newton's second law, we know that the resultant force on the electron in the y direction is that due to the electric field, which is minus Fe, which is the magnitude of the charge Q times the electric field strength E, and by Newton's second law is the mass of the electron times its vertical acceleration. So we have minus the magnitude of minus E times Ey equal to me times ay, which means the vertical deflection or the vertical acceleration is minus the magnitude of minus E times Ey divided by the mass of the electron. So the time it takes to travel through the plates can be found from the equation V naught x is equal to delta x by delta t. And so this time delta t is the horizontal distance delta x divided by the initial speed in the x direction, which should remain constant. Now the position along the y-axis can be found from kinematics, and this is the initial position y naught plus the initial speed in the y direction v naught y times the time delta t plus a half times the acceleration in the y direction times the time delta t squared. And so this is 0 plus a half times the acceleration times delta x over v naught x squared, which can simplify to ay delta x squared divided by 2 v naught x squared. And so this can be written as minus the magnitude of minus E times the electric field y component Ey over the mass of the electron times the horizontal distance delta x squared, all divided by 2 v naught x squared. And so simplifying, this becomes minus E times Ey minus of minus E times Ey times delta x all squared, all divided by 2 me v naught x squared. And so we can write this as minus E Ey delta x squared divided by 2 times the kinetic energy, 2 times twice the kinetic energy, 2k. And so this is minus E Ey delta x squared divided by 4 times the kinetic energy k, which means we can rearrange and solve for the kinetic energy through the plates. And this kinetic energy k is minus the magnitude of minus E times the electric field Ey times delta x all squared over 4y. Putting in our values, this is minus the magnitude of minus 1.602 times 10 to the minus 19 coulombs multiplied by the field strength, which is 12 times 10 to the power 4 newtons per coulomb times the horizontal distance 0.06 meters squared divided by 4 times the separation between the plates minus 0.01 meters. This gives us a kinetic energy of the electron to be 1.73 times 10 to the minus 15 joules.